Okay, today we're going to go through the test review for the chapter 1 to 3 test. And we're going to start with question number 1. It says 7y minus 14x equals 42. And our job in this problem is to solve for y. So the first thing I recognize is that this is the only y in the problem. So my job is to peel all the layers off that are around it. And I always start with the simplest types of math. And the simplest math is addition and subtraction. I notice on this side I have a minus 14x, so to get rid of that I would add 14x. That's simple math. Now 14x doesn't actually combine with 42, but here the negative 14x and the 14x make what we call a zero pair. They cancel out. But we end up with 7y on the left equals, and you can write 42 plus 14x or 14x plus 42. Typically we write them in this slope-intercept form. That's how it looks right now, but if you wrote 42 plus 14x, it would not be wrong. And then when I divide by 7, it's important that I divide each piece by 7. Technically it is right to write 14x plus 42 all divided by 7, but because these actually do divide by 7, it's preferential that I actually do the division. 14 divided by 7 is 2x, and that's plus 6. And there's the answer to question number 1. Question number 2 still has the same instructions. It says to solve for y. The issue here is that instead of having a y that's easy to isolate, we actually have two y's. There's a y here and a y here. And so the first thing we want to do is try to find a way to get them on the same side of the equal sign. Let's start with that step. And so to do that, I think it'd be pretty easy to just add 10y to both sides. That's going to give me xy plus 10y equals 22 as those two cancel. Now comes the issue. I can't combine xy and 10y because the first term has x, the second term doesn't. But because both of them have a y, I can factor out the y. Think about distribution in reverse. Okay? So for instance, if there was a y on the outside of the parentheses and I wanted to distribute inward, what would have to exist in this parentheses? If I think about taking the y off there, I'd be left with an x, and I'd be left with plus 10. If you were to think about going back into the parentheses, it would recreate xy plus 10y. So that tells me I haven't done anything wrong, and that equals 22. All I have left is to recognize that this is a multiplication problem, and so if I divide by x plus 10, something divided by itself is 1, so that's gone. But to do that, I have to do it here as well. So now my answer would be y equals 22 over x plus 10. Okay, so there's two different types. One where there's just one y in the problem, and one where there's multiple y's in the problem. And we have to get them on the same side and factor them out. The second question talks about building a formula off of an xy table. Now this xy table has 2, 3, 4, and so on for the x's. On the y's, it's 34, 28, and 22. So the first thing I want to look at is what's the pattern as I go this way. I'm noticing the numbers are getting smaller, and if I look real close and I think about it, it looks like I'm subtracting 6 each time as I go from one term to the next. So that tells me, when I think about y equals mx plus b, that negative 6 would be my slope. It's the amount I change. So y equals negative 6x. But the problem is I don't know what b is. You have to remember that b is the value of y when x equals 0. So I need to figure out what happens when x is 0. Now on the test there may not be room to do this, but I'm going to squeeze these in anyway, because I want my x's to go all the way back to 0. If subtracting 6 moves me to the right, then to go this other way I would have to add 6, making this be 40, and again adding 6 to make 46. So that tells me I need to add 46. So you have the slope value, and then you have the number that your value is when x is 0. So that was question number 3. Question number 4 is a word problem. I'm going to read it and then we'll just go from there. It says you want to hang 6 posters on a 12-foot wall. So I'm going to stop right there and I'm going to draw a picture. This is question number 4. 6 posters. 1, 2, 3, 4, 5, 6 posters. This is a 12-foot wall. Okay. It says with the same size gaps between the posters and on the edges of the wall. So that means we want all of these gaps here to be the same size. All of them, including the edges here. So we don't know how big that is. We're going to call that X. Okay. However big that gap should be. We want it to be the same the whole way. It also says that each poster is 10 inches wide. Okay. How much distance would be between each poster? So these are 10 inches. 10 inches, 10 inches, 10 inches, 10 inches, 10 inches, and 10 inches. So one of the first problems I noticed with this is that I've got feet here, but inches there. So I'm going to change the 12 feet into inches. It's 144 inches. That's 12 times 12. 12 inches in a foot times 12 feet. It's 144 inches. That's just a secondary thing. I don't think that happens in the other problem that's actually on the test, but you might have to convert units if they don't match. At any rate, each poster is 10 inches wide, and now we want to figure out how big this gap is. Well, how many posters do I have? I've got 1, 2, 3, 4, 5, 6. That's 60 inches, right? Because there's 10 inches each. So I'm just going to subtract 60 inches. I'm going to write out here, this is the posters. Okay, so I'm subtracting the posters. That leaves me with 84 inches. The next question is, how many gaps do I have to fill? There's 1, 2, 3, 4, 5, 6, 7. And so that means this 84 needs to be split 7 ways. So I divide it by 7. It goes in there once and 12. So it ends up being 12 inches or 1 foot between each poster and on the edges of the wall. Now, there is another way to do this without being quite as this is a pretty simplified approach to the question, which is great. But another way to build the problem would be to say that I have 7 X's plus 60 inches of poster, and that equals 144. If you look at the 2 steps we did, we would minus 60. That would again give us 84 equals 7x, and the last step would be to divide by 7. So we get the same answer either way, but there is more than one way to do the problem. Okay, let's go ahead and look at question number 5. There's a set of data. It's -3, -6, -1, 0, 4, 2, 4, 3, and 6, 9. And the question is this a function, yes or no? And you have to explain it. I'm going to say no because the x value or input or domain value, however you want to put that, all right, domain value, you can also just use x there, or the word input. Any of those 3 is interchangeable in this case because the domain value of 4 gives more than one range value, but range can be switched to be y or output. This is a standard answer. The only thing you'd actually have to change is if it was a different number than 4 that was the x, then you'd have to switch which one. But you see how 4 gets used twice? That's indicating to me I don't know what the answer is when I use 4 as my x value. I'm getting more than one answer. Okay. All right, so we move on. Looking at question number 6, it's asking us the same question about what we end up calling a sine curve. Looks something like that. And the question is this a function? The rule is that if we take a vertical line and we move that vertical line around, do we ever touch the curve more than once? The answer is no. It's always only going to touch the curve one time at any given spot. Now right here I obviously did a bad job of drawing it, so exclude that. But generally speaking, no, we're not going to ever touch the curve more than once, which means yes, it is a function. It passes what we call the vertical line test. All right, so we move on. We're going to keep cruising. 7, we start into graphing. And so on question number 7, we have y equals negative absolute value of x plus 4 minus 2. Now, if you remember the formula, y equals a x minus h plus k, you remember that you always switch the one that's with x and you leave the other one alone. What we're looking for to start with is the vertex. And so in this problem, we're going to say that the vertex exists at the opposite of what's grouped with x. Well, this is a plus 4, so I'm going to use minus 4. And this is a minus 2, and it says to leave it the way it is. I'm going to take minus 2. That means I go over 1, 2, 3, 4, down 1, 2, put a dot. And then from there, I'm going to use the number that's in front of the absolute value to determine the slope. Here, the slope would equal negative 1. That means on the right-hand side, I'm going to come down 1 and over 1 to create this side of the curve. And then I would mimic that to the left to create the left side of the curve. So there's my graph. It is important that you state the vertex. But if you were there the day of the test and you were having a hard time getting it graphed right, you can go to y equals, start with a negative, because that's how it starts. The absolute value function is actually in the F2 function, so we're going to hit alpha and window. That pulls up the ABS, the absolute value. Now we're going to have x plus 4 outside the absolute value minus 2. If I go to the graph of this, that looks an awful lot like my graph. If I want to know that vertex for sure, I can kind of tell it's over 4. It looks like it might be down 2. Let's look at the table. Go to negative 4. Sure enough, right here, negative 4 does make negative 2, so that is a good point. But also look at these numbers. Do you see the negative 3, negative 4, negative 5? Those numbers are getting smaller. Negative 3, negative 4, negative 5. Again, we see the slope going down away from that. So I think we're pretty confident that that's the graph. When we look at question 8,